See, Asha, when you can apply this first of all. See, when F net on the body is equal to 0, external force is 0, net force is 0, then you can apply this law of conservation also. When F net is 0, if the body is in rest, by chance, if the body is in rest, will be in rest because net force is 0 on it. If the body is have some velocity v, it have the same velocity because force is 0. If force is 0, mean what is 0? Acceleration 0. If acceleration is 0, velocity will not change. Then what is law of conservation of momentum says? The total momentum before collision is equal to total momentum after collision. So what it means, see, there are two bodies there. Okay, see, let it be this is body 1 and one more body there. Two cars are there. They are moving, let it be. Okay, after collision, this is, see, they are moving. It have some velocity. Initial velocity we represent with u1. This also moving with an initial velocity ut, and its mass is m1. Its mass is m2. Okay, both are moving. So when they will hit, whose velocity should be bigger? M1's velocity should be bigger. Like means, if u1 is greater than u2, u1 is greater than u2, then they will collide. So at some point of time they collide. So after collision, what do you think their velocities will change, right? So first one velocity will become something and second one velocity also become something. So this mass m1, its mass m2, its velocity becomes v1, its velocity becomes v2 after the collision. Here collision occurs. Now what law of conservation of momentum says, if next external force is 0, external force is not there, nothing there, they collide. Now momentum is always conserved. So what I can say, m1 u1 plus m2 u2, momentum before collision, total momentum you see, is equal to total momentum after collision. Momentum formula basically mv, mass into velocity, right? Mass into, so here you see mass into velocity of first one, mass into velocity of second one is equal to m1 v1 plus m2 v2. This is basically law of conservation of momentum. First one, elastic. First one what? Elastic collision. In the elastic collision, see, there is no loss of energy. Elastic collision means what? No loss of energy. See, if there is no loss of energy, then you can conserve energy also. So in the elastic collision, you can conserve momentum, conserve P, conserve P, conserve means this formula you can apply, as well as kinetic energy also conserve, means basically total energy. So but they are on the ground, so potential energy is 0, so kinetic energy you can conserve, means what you can write, tell me. So you can say energy before collision. So what is energy before collision? Huh? Say kinetic energy half mv square m1, its velocity u1 square plus half m2 u2 square is equal to half m1 v1 square plus half m2 v2 square. Correct. Energy also conserved. So this is your first kind of collision, that is elastic collision. Inelastic collision. What? Perfectly inelastic. Perfectly inelastic. Here what happens? Loss of energy. Conservation. You cannot apply energy conservation. Understand? So what you can apply but momentum conservation you can apply. What is that? Tell me. According to this diagram, can you tell me the momentum conservation? Huh. First body momentum is before collision m1 u1 plus m2 u2 is equal to m1 v1 plus m2 v2. You can apply this. In perfectly inelastic, what happens? You know, most in the perfectly inelastic, after the collision, both the bodies stick together and they will move. Yes, both the bodies are stick together and they move. If I say that, meaning is these two bodies will stick together, and what is this mass becomes? Excellent, m1 plus m2, and the both are moving with same velocity v. So I can write like this: m1 u1 plus m2 u2 is equal to m1 plus m2 into v. You can apply in this way also. Anyway, no issues. Elastic. In perfectly inelastic, what happened? Both the bodies stick together and they are moving. Here, nothing like that. They will move with different velocities. They move with the like this. They move with different velocities. Now, momentum conservation. Energy. Here also loss of energy. Here also, if loss of energy is there, can you apply energy conservation? No, you cannot apply. Cannot apply energy conservation. Okay, you cannot apply energy conservation. But momentum conservation we can apply. What is that? Tell me. M1 U1 plus M2 U2 is equal to M1 V1 plus M2 V2. It is greater than 0, less than 1. 1 for perfectly elastic, 0 for perfectly inelastic, and within these values for partially elastic. What is E? E. Velocity of separation by velocity of approach. Means what it is? Final velocity is difference v2 minus v1 by initial velocity is different u1 minus u2. Okay, this value gives you coefficient of restitution. What it is? Coefficient of restitution. Okay, now in some cases, like you can see, for example, a ball is there. One example we will see: a ball is there which fell down on the ground from the height capital H, and it will bounce back, right? So will it go to topmost position, or it won't go, right? It will reach to some small h, and when it is falling down, its initial velocity is 0, and it will fall with final velocity v, and it will bounce back with some velocity, right? That this is v1 and this is v2, and the final velocity will become 0. Until that it can reach to height, right? Correct. So E definition is v2 minus v1 by u1 minus u2. Let's see how much you understand. Listen. See here, two bodies should be now in collision. Ball is the first body. What is the second body? Ground. Excellent. Ground. Tell me, u1, u2 are the initial velocities before collision, right? So here in this case, let it be first body is ball. No, v1 is the velocity of the ball before collision. Velocity of the ball before collision, you see, it is not initial, it is initial velocity. We are not talking about initial velocity. Velocity at which the ball strikes the ground is v1. And what is u2? Initial velocity of the earth, ground, 0. It won't change. See, what is v1? Velocity of the ball after the collision, immediately after the collision, it is v2. And I can say what is v2, and this is, you can take different terms in this formula. What is v2? 0. So can I take this as you won't get confused. This I'll take it as v. Okay, this term I'll take it as v. v1 is acha. This is also different there, right? Okay, this is, I'll take it as v initial, v final. Okay, this is v initial, v final. Again I'm explaining. u1 means initial velocity of the ball just before collision. Before collision, vi. v1 is final velocity of the ball after just collision, and u2, v2 are the earth. It won't move, 0. So just substitute here. E is equal to v2 0 minus v final, okay, by u1 v initial minus 0, and apply sign convention. V initial is the downward, you take it as negative, v final you take it as positive, and wherever vi there, put minus. So what you got? Minus vf by minus vi, minus minus cancel. So I got V final is equal to E times of V initial. Understand? In the same way, if you solve for height, just put it. What is V initial? V final value. V is equal to under root 2GH. Do you remember that formula? V final is equal to under root of 2G. This is small h is equal to E into under root of 2G. This is capital H. Squaring on both sides. So it becomes 2GH is equal to E square times of 2GH. Capital H, 2G, 2G cancel. Means final height will be E square times of initial height. These two forms. Okay, Asha, clear? So this is fully called 1D collision, one dimensional collision. Now let's see 2D collision. Now you see, it is going straight. This is the direction of it is. This is also direction is this. Now they collide. Its velocity is u1 initial velocity. Its velocity is u2 initial velocity. Better. This is one ball there. This is another ball there. They collide. Okay, and you see this is the velocity of the first one, and this is the velocity of the second one. First one u1, and this is u2, and I want on this line what is the velocity is correct. Their velocity is on this line I want. So let's do it. See, we know this angle. One second. We know this angle is theta. This angle is theta. If this is u1, then this will be u1 cos theta, and this will be u2 components I am taking, u2 cos theta, and another component, two components will come, right? Another component perpendicular to it, right? So draw perpendicular to this one line. Okay, something perpendicular like this. This is another component will come. For this also another component you draw. This is another component. So what is this value? This is u1 sin theta. What is this value? This value u2 sin theta. Remember, the components which are perpendicular to the line of contact, line of impact. This line is called line of impact. Line of impact. The velocity is on the line of impact. You see, this is the case. We can apply energy conservation, momentum conservation. So m1 u1 cos theta plus m2 u2 cos theta is equal to something you will get m1 v1 plus m2 v2 of x direction you will get. Okay, and the velocities which are perpendicular to the line of contact, they won't change, they will be retained as it is. Okay, so what is the point here? Take away point: velocity is perpendicular to line of impact have no change, have no change, they won't change, they will be as it is. So you have to take as it is in the v1 v2 also, v1 v2 also. So you have to find out v1 x. I am saying, you see, that's why I am saying v1 x. Then what is v1 y? V1 y is u1 sin theta, v2 y is u2 sin theta. So you have to find out v1 x and v2 x here. You can get that. Okay, so this is your 2D. So basically, on the line of impact, the velocities will change. Perpendicular to the line of impact, the velocities do not change. Clear? That's it for today. Ball P of mass 0.5 kg moving with velocity 10 meter per second collide with another ball of Q of mass 1 kg at rest. Let's make the diagram first. So there are two balls are there. One is P, other is Q. Now collision takes place. First one mass is 0.5 kg, next one mass is 1 kg. This is moving with velocity 10 meter per second, and this is at rest. Okay, its velocity is 0. Then the ratio of the velocities, coefficient of restitution given, E value given, 0.4, and the ratio of the velocities of the balls P and Q after the collision. Okay, fine. So after their velocities will change, right? It becomes V1, it becomes V2. First one velocity V1, second one velocity V2. Its mass is m1. That is same. Like how much it is given? 0.5. Its mass is 1 kg. Apply the momentum conservation because external force is 0. First one m1 u1, m1 is 0.5 into u1 is 10 plus m2 u2, this is 0, is equal to m1 v1 0.5 v1 plus m2 v2, m is 1 into v2. So if you solve this, this will be 5. 5 is equal to 0.5 v1 plus v2. Let this is first equation. Now coefficient of restitution given. We discussed the formula. Coefficient of restitution v2 minus v1 by u1 minus u2. Velocity of separation by velocity of approach, right? This is 0.4. Can I write 4 by 10? It will be easy. V2 we don't know, V1 we don't know. These are the velocities after the collision. This you have to find out the relation. U1 10 given, U2 0. This is 4 by 10. This said 10, this said 10 will get cancelled. So I got basically V2 minus V1 is equal to 4. Equation number 2. Solve 1 and 2, you will get the answer. First equation what? First equation is 0.5 in terms of V2 first. Here I will write, it will be easy for me. V2 first equation, yeah, first equation I am writing here, plus 0.5 V1 is equal to 5. Subtract, minus, minus, minus. These two will cancel. Minus 1, minus 0.5, minus 1.5 V1 is equal to minus 1. Minus minus cancel. So I got 1.5 V1 is equal to 1. 1.5 means 3 by 2, V1 is equal to 1. I will get V1 is equal to 2 by 3. Okay. This equation number 3, put this in second equation, it will be easy. Second equation what? V2 minus V1 is equal to 4. So V2 is equal to 4 plus V1, that is 2 by 3. V2 is equal to 4 is 12, 12 plus 2, 14 by 3. They want ratio. Ratio of velocity is P by Q, V1 by V2. Okay, you will get the answer. V1 by V2, right? V1 by V2 they want. V1 how much? 2 by 3 will get cancelled by 14. Answer 1 by 7. So first option is the correct answer. Thank you. Ball moving with velocity V, collide head on with another secondary ball, stationary, which is stationary second ball. Okay. So there are two balls there. First one is moving, second one is at rest. First one is moving with velocity V, this is at rest. So this is your U1 initial velocity, U2 0. Both are same mass. Okay, this is M, this is also M. So after collision what happens? After the collision the velocity of the first ball is reduced to, so this is after collision, two balls. Okay, mass M, mass M. This velocity becomes 0.15 V and the kinetic energy of the system is decreased nearly. Its velocity not given, V2. Okay, see, energy decreased means it's not elastic collision. Okay, so you do one thing, first apply momentum conservation. So m into u1, that is v, plus m into u2, that is 0, is equal to m into v1, that is m into 0.15 v plus m into v2. This v2 we don't know, so you can cancel m. So v is equal to 0.15 v plus v2. You can find out v2 is equal to, transpose that side, 1 minus 0.15, 0.85. Correct, 0.85 v. This is your first equation. Coefficient of restitution, no. So okay, you got v2, right? V1 already given. Total energy we can find out, the kinetic energy of the system decreased nearly. So kinetic energy, initial kinetic energy of the system, it have only one energy, that is kinetic energy of the first body. Second body kinetic energy 0. So it is half m u1 square, because u2 is 0. So it is half m
u1 square is v square. So it is basically mv square by 2. This is the initial kinetic energy. Now I want final kinetic energy. Final kinetic energy is because of kinetic energy of first body plus kinetic energy of second body. That is half m v1 square. v1 is 0.15 v whole square plus half m 0.85 v whole square. So half m you can take common, half mv square you can take common. So what is left here? Half m gone, v square gone, 0.15 whole square plus 0.85 whole square. This squares you add. Now half mv square, 0.15 whole square plus 0.85 whole square. Calculate it. This value you will get 0.745. Okay, calculate it. Now what they are asking? The kinetic energy of the system decreased nearly in percentage. So this is initial, this is final. How much decreased? So change in the kinetic energy percentage is equal to how much it is decreased is change in kinetic energy by original kinetic energy into 100. So original how much? Half mv square minus how much it is final? Half mv square 0.745 by original half mv square into 100. See half mv square, half mv square, half mv square cancel. Basically 1 minus 0.745 into 100. So this value you will get 0.25 around, right? 0.255 into 100. So approximately 25 percentage you will get. 25.5 percentage is the required answer. So verify the option, check the option. Option B is the correct answer. Thank you.